Hello and welcome to the Tudor Grange Science Department's guide on how to carry out scientific experiments. So, you've been given a task of carrying out a scientific experiment. This could be part of a classroom practical. This could be part of a APP project, which you will encounter in Year 7 and 8. This could be part of some coursework, which you will encounter from Key Stage 4 upwards. Or it could also be part of our newly introduced controlled assessments. So, where do we begin when we're starting to look at these 4 ways that we can carry out an experiment? Well, in our science department, we try to look at doing a step-by-step procedure. So we try to lay out exactly how we're going to tackle our science experiment. So number 1, we would like to try and pose a question. What is it that we're trying to find out? What is it we're trying to investigate? Number 2, we need to choose a few variables, and we'll go on to discuss these shortly. Number 3, we need to decide on a method, a detailed method. What are we going to use when? How much of are we going to use? How long do we time the experiment for? And such things like that. Number 4, choosing the right equipment. You've got to make sure that you've got the right equipment needed. And number 5, we need somewhere to actually put our results once we've actually conducted our science experiments as well. So what kind of results tables are we going to need? And finally, number 6, once we've collected some results, we can analyse our results by analysing our data. And ultimately, what we're trying to do is relate number 1 and number 6 to each other. We're trying to see, did number 6 actually prove what we were expecting up at number 1, or did it disprove something? Did your findings prove what you were expecting in your results? Okay, so this kind of method is known as the scientific method, and it's used all around the world through subjects such as physics, chemistry and biology that all start with asking a question, perhaps doing a bit of background research, designing a hypothesis, and then going into the laboratory or in the field and actually testing this with an actual experiment. It's only then, when they bring those results back, can they actually make a relationship between the end and the start once more. Okay, so we talked about variables. If you're starting science in Year 7, it's a little bit daunting to know what these 3 words actually mean, so let's just do a quick rough guide. So we have 3 different types of science variables. One is called the independent, and this is a variable that we change each time in our experiment, something that we're going to alter. What is it that we're changing in our experiments? We need a dependent variable. This is a variable that we look at. This is the one that we're interested in watching what happens with. Does it go up? Does it go down? This is the part of the experiment that will change because of what we are changing earlier on the independent variable. And also we like to keep something the same, and we call this the fixed variable. We like to keep something constant throughout the entire experiment. So whenever you're doing a science experiment, think, what thing am I not changing? What am I keeping the same? And that will be your fixed experimental variable. So going back to our method, make sure that your method's detailed. Make sure that you write as if you are communicating to somebody else how to conduct your experiment. Make sure you collect the following. Measure out perhaps a certain amount of. Using 3 spatulas of. All of these steps will help somebody else carry out your experiments. And also we could have a look at repeating steps as well. Doing an experiment more than once helps us collect a lot of data, so we can look at a huge wide spectrum of our experiment and actually try and then find out things like averages from our experiments. If we're going to use a results table, make sure that we've got a few key points. So number 1, make sure that your results table makes sense. Make sure that when we use units to describe certain things, such as temperature, and if we were using degrees Celsius, that we put the units at the top of the table only. And the same for if we were measuring time, we put seconds at the top of the table only. That way, any numbers that go beneath these 2 headings will ultimately mean degrees C or seconds. We shouldn't have to keep writing the units all the way down. And this sort of table we could use for one of our experiments in our Key Stage 4 lessons, looking at the specific heat capacity of water. We could also have a look at slightly more advanced results tables, perhaps when doing a physics experiment. This one is just an example of when we're looking at the energy of a ball rolling down an inclined slope. We could have a look at plotting out the height, the length, time, speed, and perhaps an average. Going back to what we said earlier on, collecting more than one set of results allows us to actually calculate an average. Look at how we've used the units again once more at the top of each table. So centimetres at the top, seconds, centimetres per second, centimeters per second here. It means we don't have to keep writing the units in the tables below. We just have to write it once at the top. Okay, so once you've collected your results, what are you going to do with them? How are you going to present your findings? Well, we've got the good old-fashioned bar charts that we can sometimes use, but as we move through science in secondary school, we tend to try and evolve, and we try and use our graphs as best as we can to perhaps move on to ways of doing line graphs instead of just bar charts all the time. And using line graphs will enable us to do a few good points. We can have a go at plotting lines of best fit. If the data looks as though we can use a line of best fit, we can have a go at sloping curves on a graph. Do our points curve? Will this set of points match a freehand drawn curve in pencil? Or will it match better to a line of best fit? Sometimes bar charts are necessary, but we're trying to move forward and try and see if we can use a line graph to communicate our findings a little bit better. Okay, so here's a few key points. You can always come back to this whenever we're doing our graphs. So when you're plotting your graphs, have a think, which variable goes on which axis of the graph? What am I going to put down the y-axis? And what am I going to put across the x-axis? Label each axis correctly. Is my graph going to look better portrait or landscape? Always use a pencil and a ruler. Always remember to use a pencil and a ruler. Use the correct units. Plan it out rough first if you have to. And if you find any anomalous results, any numbers that do not seem to fit the rest of the graph, put a circle around them and label these as the anomalous results. Results that don't perhaps fit the rest of the graph. Okay, and then finally, right at the end of our experiment, we're going to conclude and evaluate. So these questions could be slight prompts for when we're doing our experiments. So what did your results tell you? What does that therefore mean? Are you able to tell somebody else about what you found out? Can you also tell somebody else about your experiment using numbers, and also to get even higher marks on experiments, can you back up your explaining with actual science relating to your actual experiment that you did? How does it relate to the wider world? And then of course we need to evaluate the whole process. What do we do well in our experiments? How good and reliable are your results? Is your data valid? Could we use it somewhere? Could we use it in an argument? What didn't work so well? And what could we change or improve next time if we wish to do this experiment all over again? Well, this has just been a short video to get you started on thinking the best ways how to set out a scientific experiment either in school or as part of a project at home. So thank you for watching, and we hope this has given you a little bit more confidence to tackle some experiments.